Okay, so let's start by reviewing what we talked about on Friday. We went over how to find the slope of a line, and that's going to help us with what we're leading into today, where we're actually finding the slopes of these figures to figure out what shape we're actually making with these, okay? And so if you remember from Friday, we talked about that slope is rise over run. Okay, positive slope lines, of course, pointed in the upward direction, and negative slopes pointed down. Okay, and so looking at the first example here, remember we're counting slope, so we count rise over run. So from one point to the other, we rise 1, 2, 3, 4, 5, 6, 7, and then we run 2. So we go over 1, 2. So on the example 1, slope was 7 over 2. Okay. Looking at example 2, okay, this slope pointed down, it was negative, and so we went down 1, 2, 3, 4, 5, 6, and then we ran 1, 2, 3, 4, 5, 6. And negative 6 over 6, we reduced the line to negative 1. Okay, so the key here is to remember slope is rise over run. Right, we're going to use that knowledge to talk about today's lesson, and we're actually looking at figures in the coordinate plane. Okay, so let's just classify the first one here. Okay, QRST, and please notice that on this first example here, there was a typo. Okay, and please notice the new vertices for our new points. So Q is at the point 1, 1. R is at the point 2, negative 6. S is at the point 3, 3, and T is at the point 4, negative 4. So please make sure that you make those corrections on your paper. Okay? And then what we're going to do is just plot these points on the graph. Okay? What I suggest doing is darkening up the XY axis so that you can see a little bit better exactly where our starting point is for each one. Okay, so I'm going to make those a little bit bolder here. Right, and then I'm just going to plot my points. Okay, so Q is at the point 1, 1. R is at 2, negative 6. S is at 3, 3. And T is at 4, negative 4. Once you have all your points plotted, okay, go ahead and connect the dots. And obviously we're making a four-sided shape. Okay, so we connect the dots to make some sort of four-sided shape here. So now that we have all of our points plotted, the lines connected, what we're going to do is count the slopes for each of the 4 lines. Okay, so I'm going to start with this side QS. Oops. Let's make my pen not as big. Okay, so the line QS, we count the slope. So from Q to S, I go up, rise 2, and then I run 2. Okay, so my slope here is 2 over 2, and I can reduce this slope 2 over 2 to just 1. Okay, and I'm going to do the same thing for the side that is parallel to QS. And the side that is parallel to QS is RT. So my next slope that I'm going to look at is the side RT. Okay. So for the slope for R to T, I go up 2 and over 2. So my slope here would be 2 over 2, which again we know reduces to just 1. Okay, let's look at the slope of the other 2 lines. So I have the other line, QR, Okay, and for this slope, I'm going to go down. So it's negative. So from Q to R, I go down 1, 2, 3, 4, 5, 6, 7. So negative 7. And then I run 1. So negative 7 over 1. And negative 7 over 1 reduces to just negative 7. And I'm going to look at the slope at the line that is parallel to QR, which would be ST. And it doesn't matter what order you do these in, okay? I just typically pick whatever line I'm looking at first. All right, so from S to T again, I'm going to go down. 1, 2, 3, 4, 5, 6, 7, so negative 7. And then I'm going to run 1. So negative 7 over 1, we said reduces to negative 7. Okay. So QS and RT had the same slope. And QR and ST had the same slope. Okay, but what I want you to notice is that all 4 of these are not the same. I got 1 for 2 of the lines, and I got negative 7 for the other 2. Okay, in this case, this figure here is a parallelogram. Okay, for parallelograms, 2 of the slopes are going to be the same, okay, but all 4 will not be the same. So let's take a look now at the second example here. And again, my starting point here is that I'm going to darken up my XY axis so that I can see those better. And then I'm going to plot the points for each of the vertices. Okay, so I have points at A is negative 3, 0. B is at 4, 7. C is at 9, 2. And D is at 2, negative 5. Okay, so we're going to plot these points. So A is at negative 3, 0. So it's actually on the x-axis. B is at 4, 7. So 1, 2, 3. C is at 9, 2. And D is at 2, negative 5. Okay, again, we're going to have a 4-sided shape, so go ahead and connect the dots, okay, to create that 4-sided figure. So now let's look at the slopes of the lines. So I'm going to start with the line AB. And let's count the slope for that line. So I rise 1, 2, 3, 4, 5, 6, 7. And I'm going to run 1, 2, 3, 4, 5, 6, 7. And we know that the fraction 7 over 7 is going to reduce to 1. Okay, we want the slope of the line that is parallel to AB, which would be the line DC. And again, we're going to count the slopes. So from D to C, I rise 1, 2, 3, 4, 5, 6, 7, and I'm going to run 1, 2, 3, 4, 5, 6, 7. 7 over 7 again reduces to the slope 1. We're now going to count the slope for the other 2 lines. So I'm going to count the slope for AD. From A to D, I'm going to go down, so that's going to be a negative. I'm going to go down negative 1, 2, 3, 4, 5. And then I'm going to run 1, 2, 3, 4, 5. So negative 5 over 5 would reduce to just negative 1. Now I want the slope of the line that is parallel to this. So that would be the line BC. And again, I'm going to go down, so that's negative 1, 2, 3, 4, 5, and then I'm going to run 1, 2, 3, 4, 5. So negative 5 over 5 we said reduces to negative 1. Okay, so in this case, my slopes reduce to the same number, but they're not actually the same number if I just count them. This shape is going to be a rectangle. And remember with rectangles that we know that two sides are equal and the other two sides are equal. Okay, but one of them are going to be bigger than the other. Okay, so in this case, the slopes are going to be the same. They're going to reduce, have opposite signs, but the slopes are not actually going to be equal to each other. Okay, so let's look at the next page. All right, and we're going to classify quadrilateral, okay, ABCD, with the vertices at 1, negative 4, 3, 0, negative 1, 2, and negative 3, negative 2. Okay. So let's plot these points. I'm going to darken my XY axis first so it's easier for me to see. All right, and we're going to plot the points. I'm going to start with A is at 1, negative 4. B is at 3, 0. C is at negative 1, 2. And D is at negative 3, negative 2. And we're going to connect the dots to make a four-sided shape. Try to draw my line straighter. So now that we got the shape drawn, let's go ahead and count the slope for each of the sides. I'm going to start with the side. Let's start with DC. Okay, so for the slope from D to C, I'm going to rise 1, 2, 3, 4, and I'm going to run 2. And the fraction 4 over 2 reduces to 2. That's the first line, the slope is 2. Let's look at the next line that is parallel to DC, which would be AB. We're going to count the slope for AB. So I rise 1, 2, 3, 4, and I'm going to run 1, 2. And again, 4 over 2 reduces to 2. Okay, let's look at the next line. So I'm going to go from D to A. So for the slope of the line DA, I'm going to go down 1, 2, so negative 2. And then I'm going to run 1, 2, 3, 4. And the fraction negative 2 over 4 is going to reduce to negative 1/2. I'm going to count this for the side that is parallel to DA, which would be CB. So from C to B, I'm going to go down 1, 2, and I'm going to run 1, 2, 3, 4. So negative 2 over 4, which again we said reduces to negative 1/2. Okay. This shape is going to be a square. We all know that with a square that all sides are the same. They're all equal. So if I look at these, I have 4 over 2, 4 over 2, and then I flip the fraction and make it 2 over 4 and 2 over 4. Okay. For a square, the special characteristics of this is that we are going to have opposite reciprocal slopes. So opposite reciprocals slopes. Okay? The word reciprocal means the flip of a fraction. It's just that simple. So for a square, you will have the exact same numbers just flipped. So let's look at the next example here. We're going to classify the quadrilateral ABCD, and it's going to have the vertices at -1, 5, -4, 1, -1, -3, and 2, 1. So I'm going to darken my axes. And I'm going to plot my points. So the first point is at -1, 5. B is at -4, 1. C is at -1, -3. And then D is at 2, 1. So we plot our points, connect our dots. So let's count the slopes of all of our lines here. So I'm going to start with the line BA. Okay, so for BA, my slope, I go up 1, 2, 3, 4, and I run 1, 2, 3. So my slope here would be 4/3, and the fraction 4/3 does not reduce. I'm going to leave it as 4/3. Next, I want to find the slope of the line that is parallel to BA, which would be CD. Okay, so the slope for CD, I rise 1, 2, 3, 4, and I run 1, 2, 3. So again, it would be 4/3, which does not reduce here. Okay, I'm going to look at the slope of the next line. I'm going to say BC. Okay, and so from B to C, I go down 1, 2, 3, 4, so -4. And then I'm going to run 1, 2, 3. And again, 4/3 does not reduce, so I'll leave it as -4/3. And then the line that is parallel to BC would be AD. Okay, so I'm going to count the slope for the line AD. I go down 1, 2, 3, 4, and I'm going to run 1, 2, 3. So I get -4/3. And again, that does not reduce. All of my slopes are the exact same numbers. The only thing is I changed the signs for 2 of the lines. When you get slopes that are the exact same numbers, this will be a rhombus. So, for the last example that we have on our notes page here, I want you to notice that the points are wrong from what you have on your paper. So please make sure that you make these corrections to plot the points and correct your figure here. So we're going to plot MNOP. M is at -4, 0. N is at the point 1, 0. O is at 2, -3. And P is at -6, -3. So let's plot these new points here. So first thing I'm going to do is make my axes darker so I can see them better. I'm going to plot my new points based on these new coordinates. So I'm going to plot the point -4, 0. So I go -1, 2, 3, 4. And it's actually going to be on the x-axis here. I'm going to plot point N at +1, 0. O is at 2, -3. And P is at -6, -3. going to connect our points here. So let's look at the slopes for these lines. And I'm going to start with the slope of the line MN. Make my pen not as big so we can see it better. So I'm going to start with MN. Okay, for MN, to go from one point to the next, I'm not going to rise any. So if I don't rise any, that is a 0. And then I'm going to run 1, 2, 3, 4, 5. So my slope, 0 over 5, will reduce to just 0. 0 over 5 is 0. All right, I want the slope of the line that is parallel to MN, which would be PO. All right, and so from the point P to O, again, I am not going to rise any, so that would be a 0. And I'm going to run 1, 2, 3, 4, 5, 6, 7, 8. So I'll run 8. And 0 over 8, again, reduces to just 0. So I want the slope of the other line. So from P to M. From P to M, I rise 1, 2, 3, and I'm going to run 1, 2. So 3 over 2, which the fraction 3 over 2 does not reduce it. And I want the slope of the line that is parallel, well, it's not parallel in this case, okay, but the opposite line from PM, which would be NO. All right, and what is special about this shape is that we see right here, PM and NO are not parallel to each other. Okay, they're slanting opposite directions from each other. All right, but from N to O, I'm going to go down 1, 2, 3, so negative 3, and I'm going to run 1. Okay, so in this case, MN and PO had the same slope. They were both 0. Okay. But my other two lines are not the same slope. They're different. Whether they have different numbers, different slopes entirely, or just the signs are different. Okay, what I want you to notice is 2 will be the same and 2 will not be the same. When we have this case, then this figure here will be a trapezoid. Okay, and based on the slopes, that's how we classify our figures. We're going to have 5 that we're talking about here. We talked about a trapezoid, a parallelogram, a square, a rectangle, and a rhombus. All right, looking at your assignment, which is the bottom of this page and then the back of this page, there are actually 6 questions on your homework. All right, we have 5 different shapes that we're talking about. So one of the shapes will repeat, okay, but only one, and then all the rest will only have one of each. Okay, so I'd like for you now to attempt your homework, work these problems out, and then we will talk about the answers to these tomorrow during class.